All right, so we're going to get started. We are going to talk about how your car isn't. My name is b1tbane. There's also some who call me Tim. I am a largely recovered software developer. I spent most of my career writing embedded systems for planes and the types of planes that you fly from the ground and cars. Somewhere along the way, I become a hardware guy. Still not quite sure how that happened, but people keep asking me questions about hardware, and I know the answer, apparently. So I've been doing that a lot recently, and I still get a bit twitchy around certain aircraft.
All right, I'm ehntoo. In meat space, most people call me Mitch. I am also a recovering software developer. I'm not quite as recovered as Tim is, but get in there. I've had a passion for embedded development for a long time, but for many years I was paying the bills doing web dev. It's a lot more fun breaking stuff. So that's what I do now full time.
So this is your car. This is what it looks like now. There aren't things like carburetors. Don't replace your jets and tweak your idle screws to tune your car anymore. You do it a little bit differently these days. Your car is actually a network. Bunch of different components connected over typically CAN bus, other types of buses that we'll talk about later. And actually, we lied again. Your car isn't a network. It is a whole bunch of networks. There's a bunch of stuff on there like there's CAN, Ethernet, LIN, there's wireless, Wi-Fi, Bluetooth, cellular radio, wireless for your tire pressure sensors. They're going to be putting another radio on there for autonomous driving called a DSRC radio. I just see attack surface.
So they're just networks. We've been protecting and working on networks for dozens of years now. We know how to do that. No, not quite. These are not the networks you're used to. So there's a bunch of standard techniques that used to be employed and are still employed for standard like TCP/IP networks that don't work on CAN bus for a variety of reasons, which we will talk about now.
So CAN bus has a tiny payload. It's 8 bytes in a packet. Now there are standards like ISO-TP that allows you to send more traffic on the CAN bus, but CAN bus is also slow. About 500 kilobits per second is typical in a car. And there's a lot of data on a CAN bus. If you hook into a CAN bus, we have our demo out in the car hacking village. You can hook into the bus, see the traffic. There's a lot of stuff going on there, and making it longer and making it take longer to process isn't always an option. Your processors on a lot of these ECUs are 8 16-bit micros with, I can count the flash and RAM on my fingers in kilobytes. Very, very small processors. This also makes things like authentication. A lot of these things are also very safety critical, very time-sensitively safety critical. So you had a bunch of overhead, to do authentication, had a bunch of overhead to do your encryption. All of a sudden, you can't hit your timing requirements for safety anymore. You also have the question of protecting the keys. We actually give cars to people. I don't know how many of you realize this, but everybody who owns a car owns a car. And they have access to all these things that are in the car. And if you're going to ship the key with the car, it's only a matter of time until somebody rips it out of there.
Traditional networks use things like firewalls. They tend not to work quite so well in a CAN bus network. If you have any sort of message passing ability, lots of the time the messages which are normally passed in the course of normal operation can be used against you. So on most vehicles, there's some sort of diagnostic methodology where you can actually pulse the ABS modulator to bleed brakes. That's a normally allowed message, so it gets through a firewall. On the CAN bus, there is no way to determine what node on the bus is sending a network. So once the message gets on the network, it's indistinguishable from any other node's messages. So if the message can ever appear on the bus, it's basically forced to be treated as valid.
So what about intrusion detection system? Something a little bit smarter than a firewall that's able to say something like, hey, we're trying to bleed the brakes, and we're going 70 miles an hour down the interstate. This probably shouldn't be happening. And while I'm not denying that this could be a part of the solution, what do? You can't just disable the ABS module because you kind of need that. You can't just pull over the side of the road because that might not be a safe thing to do at the moment. So there's a question so you have this IDS that alerts you, which is great, but what do you do about that? And what do you do with that alert? It's like the check engine light. You're going to take it to the mechanic in 3 months and see what's up with that.
So what can we do? Segregating networks is a great first step. You can't hack or influence what you can't talk to. So if you have dedicated buses for just talking between the power steering and I don't even know what needs to talk to the power steering most of the time. Usually the engine controller for speed-related messages. There's a lot less attack surface on the bus. So if you can't talk to your brake module from the head unit, then no one who gets into the head unit from some sort of internet connection can apply your brakes in the middle of driving. Just good things. Having some sort of internal sanity checking on each module. So I'm going 70 miles an hour down the highway. Maybe now is not the right time to try and bleed the brakes. Some of these we're starting to see in modules, not as much as we might hope. For all of these, it's just a part of a broader solution. The end solution is probably getting rid of CAN altogether, but eventually, maybe.
That's going to take a while. Yeah. So what does it mean to hack a car? Is this car hacking? This is actually more expensive than a lot of forms of car hacking that we're going to talk about. Those things probably cost $20, $30 a piece. That's a lot of money going to that Audi there.
Axes aren't cheap.
No, they are not. So hacking a car, what does it mean? That depends on who you're talking to, who's doing the hacking, what systems are in scope for the hacking that you're doing, what are your goals? Are you trying to for the modder community, they're trying to get into the ECU and do some performance tuning, that's the hacking that they're doing. There's nothing malicious about it. They just want their car to go a little bit faster. There's plenty of other things that we're going to talk about too in a couple slides. So hacking a car can mean a lot of different things. Like Mitch alluded to earlier, a lot of stuff that we found is diagnostics that are left enabled on ECUs that can be enabled at times that would be somewhat inconvenient for the driver, like the brake bleeding at 70 miles an hour. Sending CAN messages to control the vehicle, doing enough reverse engineering on the CAN bus to figure out what different messages do. Taking over the infotainment system via the internet or SMS. This is kind of getting more into your more standard Wi-Fi type hacking, where this is just the infotainment system is a full-fledged operating system. It's Windows CE, QNX, Android, running Wi-Fi, running Bluetooth. This is a lot of attack surface, a lot of what's very quickly becoming very well-known attack surface. And these are also almost always connected to the CAN bus. Now, the segregation is actually happening, and we're seeing happen in the real world that the infotainment, which used to maybe be on every CAN bus, is now only on a couple of them, which is great, especially isolating it from the safety critical systems is something that we're seeing happening now. So now you still have to pivot off something in order, because there are things that are connected to both CAN buses. We've got to find a device that's also vulnerable to compromise to pivot then onto the bus that you want to get to. GPS, a lot of the cars have built-in microphones for your cell phone, using the TPMS sensors that all have a unique ID to track a vehicle. Lots of other concerns as well. And all these different types of hackers, with different goals in mind, are going to employ various of these and other attack methods.
Something that's useful to know when you start actually looking at hacking cars is that the OEMs, so like Ford and Nissan and Volkswagen, they don't make cars. they put them together. So they subcontract construction of pretty much every assembly in the vehicle. So the primary subcontractors are called Tier 1s. Tier 1s employ Tier 2s, who employ Tier 3s, many levels deep sometimes. When you're dealing with security requirements, there's some high-level requirements that the OEMs specify when they're designing the car. This must be secure. Who knows if those actually get implemented down the line? Some of this stuff is really hard to verify experimentally.
And as also we mentioned, the relationship between OEMs and their Tier 1s and their Tier 2s and their Tier 3s isn't always necessarily a completely healthy, open, and honest one, which in some ways makes sense. I mean, these Tier 1s are working with more than one OEM. They have their secret sauce that makes their stuff better, or so they put on their marketing glossies. So they don't necessarily want to just give the OEM complete access to all of their source code, all their information, because they could lose out on competitive advantage that way. So, there's the question. What exactly do you do about that?
There's a lot of project manager chicken being played.
Yes. So who is doing the hacking? Like as I mentioned, modders. They want to add cool features. They want to make their car go faster. They want to turn their LEDs blue instead of yellow in their car. All those very vitally critical safety critical features in there. Security professionals. I hack on cars too. What to protect and against what? Like what's actually important? Where should the focus be put? And how do we address some of these fairly complex issues that face the automotive industry? Expedition engineers, code execution. Like I said, these are often very, very small micros. They're not running an operating system. There's no data execution prevention. There's no ASLR. If you find a buffer overflow, you stick your shell code on the stack, overwrite program counter, and dump to it. It's back to the 90s in terms of security, because these small processors that are in use just don't have these features. There is no operating system in use to add these features. Organized crime. This is actually the one that kind of so what keeps me up at night isn't so much hacker, Fast and Furious 8 hacker taking over the world and crashing all the cars into each other all the time. It's more targeted stuff, targeted assassination. One of the saving graces of the automotive industry is that there is so much difference in a car. Every car has different ECUs, like even between model years. What you find out on a 2012 Focus, like what we have out there, might be different, at least in some critical ways, from a 2013 Focus. So the hack that hacks all the cars just isn't going to happen because of that difference. But the hack that hacks one car is a lot more in reach. And of course, nation-state level stuff that I'm not going to get into.
In terms of organized crime, larger crime rings are starting to figure out, I can actually use relay attacks to do a remote relay attack against remote keyless entry dongles and steal cars that way. It's actually pretty easy. I think there was a good talk on it last year at DEF CON. Not sure. Yesterday. I missed that one. So how are all these various people hacking into cars? There's a lot of different interfaces you can actually get into. So all of these are networked at this point. Your OnStar uses a 4G AT&T connection that's always on. The Uconnect system is on Sprint. I don't actually know off the top of my head what other cell networks the other OEMs use, but most modern infotainment systems will be connected to a 4G network somehow. There's much lower level debug interfaces. So you got JTAG and SWD interfaces. If you can actually take the time to pull a module out of the car and tear it apart. If you have an active debug peripheral, you can dump whatever firmware you want most of the time. Even if you don't have a debug peripheral, there's other buses you can attack. If you want to reverse engineer the operation of like subcomponents, you've got SPI, I2C, and UARTs, which are commonly used to talk between modules on the same board. Firmware updates are less secure than you might hope. I don't think I've yet encountered a like submodule other than like head units that use code signing or any sort of decent integrity checking. There's lots of different radios on your cars. So your even like your FM radio, just listening to FM, if you take a look at like your head unit, it'll display like station names and track names. That's done with a system called RDS, the radio data system. In addition to just displaying like short strings of text like that, there's an entire subsystem for distributing traffic messages. So it'll actually update, on my car at least, that's the method used to add accident indicators on like the navigation system. And if you get really dedicated, you can start decapping chips to try and break into hardware security modules.
Side general analysis is a lot of fun too.
Yes, it is.
And car hacking doesn't have to be all that expensive. The Cantact Cannibal are what?
If you want to build your own Cannibal, I built them in like 15 quantity for, I think it was $8 each. It's pretty cheap. So the Cannibal and Cantact are a open source hardware CAN adapter built around a small STM32 microcontroller. The default firmware exposes it just as a UART using a standard CAN protocol. They're really basic hardware, but they work really well. Yeah. I have a bunch now.
Yeah, you can do a software-defined radio. These are obviously a little bit more expensive, but still pretty reasonable. Like a Blade RF or Lime SDR is $300-400. Do a whole bunch of different types of wireless hacking with those. In addition to your standard on Wi-Fi, just your laptop has a Wi-Fi chip on it. Just use Wireshark. And for the more esoteric ones, like your TPMS sensors or TPMS and the SDR works really well for that. There's also the Yardstick 1 and the Pandwa RF, which are slightly less capable but than SDR like the Blade RF, but still definitely quite useful. Like the Yardstick 1 was used in the roll jam attack against your car's key fob, which is a very interesting attack.
They're less capable, but they're a lot easier to use.
Yeah, that too.
If you want to use SDRs, the most common way of interfacing with them is with something like GNU Radio Companion, which is a very complex flowchart-based radio setup tool. The Yardstick 1 and Pandwa RF are all in hardware. So it's configurable, and it does multiple modulation types and encodings. But you set the hardware up, and you just do the data transfer. It's much simpler to use.
And also the question?
Yeah, the Cantact and Cannibal you're talking about, is that like a USB to CAN?
Yeah.
Okay.
Yeah.
So you're saying those are actually cheap to make? I'm seeing the ones for sale for like $395 or $299.
All the commercial ones are way overpriced.
Yeah, if you want to pay, if you want to pay Vector that much money, then go right ahead. But you really don't have to.
So where do you find the Cantacts there?
So the Cantact, I think the website is cantact.io.
Right.
I'm not sure. If you Google it, you'll find it. It's a unique project. If you Google Cannibal, you will get Google auto-correcting it to Cannibal, and that's not what you want. But if you actually tell it to search in verbatim mode, you'll find the right project. They're based on the same schematic. So Cantact was a project from Eric Evanchik, writes for Hackaday. It's literally just a microcontroller that has like a crystal on the side and a CAN transceiver. It's super basic. The one thing you don't get in this sort of hardware is any sort of galvanic isolation. So some of the more expensive CAN adapters will actually protect your PC from high voltages that the CAN bus might experience if something goes wrong. These are just directly connected. I've never had a situation where that's important, but it's something to be aware of.
Yeah. Still, a Cantac and a USB hub is a lot cheaper than anything you buy from Vector.
Yes.
We also have the CanCat. That's a tool we've developed in-house. It's an Arduino Due with a CAN shield on it, open source. If you want to see a demo, we have it at our car hacking lab out in the car hacking village. Slightly more expensive than the Cantac or Cannibal, but also has 2 CAN transceivers on it, so you can do CanCat supports what we call CAN in the middle mode, where you can isolate a device, basically use the 2 CAN transceivers as a pass-through, and you can also do filtering or modification of messages or block certain method, whatever you want to do to screw with it. It's also really nice since CAN doesn't have a source IP address. If you don't, or source address as part of the packet, if you don't know which device is sending a message, you can use that to isolate a specific device and then see which messages that device is actually sending. Otherwise, the CAN bus is just nothing but messages going back and forth and no idea where they're even originating from. Makina M2 is a Kickstarter project. I think they're going to start shipping in a couple of weeks.
I don't recall.
Yeah. It's going to start shipping in a couple of weeks. It's also based on the Arduino Due, and our CanCat firmware runs on it. Same deal, you get 2 CAN transceivers. You also get, what all do you get on it?
It does 12-volt I/O. It has single-wire CAN, also called GM LAN. It's used for lots of the lower-speed communications in GM vehicles. It does K-line. It does LIN. Basically, if it's a protocol that a car speaks that isn't automotive Ethernet, it'll do it.
J1950?
I think it does J1950.
Yeah. So, a whole bunch of stuff, especially if you have an older car you're hacking on. Modern cars mostly just have CAN and the single wire CAN if it's a GM vehicle. If you're hacking anything before about 2008, though, the Makina is awesome for that because it has all of these older protocols that aren't in so much use anymore, but were in use on those older vehicles. It's a great tool for that.
And what's the fun in giving a talk if you don't actually introduce something new? So over the past couple of weeks, I put something together we're calling CanFly. It's based on the ESP32. Has anyone heard of the ESP32? It's a IoT targeted module. It's got inbuilt Wi-Fi and Bluetooth. It does both Bluetooth Classic, Bluetooth Low Energy. It has a CAN transceiver on it, thankfully. It has 2 200 megahertz processors. It's a little bit of a weird architecture, but the tooling is a lot better than it was a few years ago. So you can actually run a modern GCC on it, which is great. No crappy proprietary compilers. The way the CanFly uses the hardware is it exposes a Wi-Fi access point, which you connect to. And then you, at the moment, the only protocol it supports is the Metasploit hardware bridge, because that seemed like an interesting place to start. The Metasploit hardware bridge is fairly new. If you see Craig Smith around, he's put a lot of work into it. Soon, you're working on adding support for our existing tooling for CanCat. And I'm working on putting together a socket CAN adapter so you can use it with whatever socket CAN stuff in Linux you might want. But the main advantage of this is that it's really cheap. So being an IoT targeted module, the ESP32, you can buy it for $750 from like AliExpress or several other Chinese sites. And then all you need in addition to that is a CAN transceiver, which you can find for as little as like $1.50 on a breakout board with all the bypass caps you need. So this is what the hardware looks like. It's not terribly impressive because it's really simple. All you have is the ESP32 module. You've got the CAN transceiver hanging out in the middle of the screen, and then I have it hooked up to an OBD2 connector. The only other thing you need for this is a 5-volt power source. Do you have anything you wanted to say?
Usually supplied over a micro USB cable on most of the ESP32 breakout boards.
Yeah, for most of my testing so far, I've just plugged it into USB power bank and let it be. At some point in the near future, we're going to put together probably a separate breakout board that you can plug it into and actually power it from your car. This really simple voltage regulator. So the demo is not particularly impressive because it's just a screencast of using Metasploit, but I was originally going to try and put together a live demo on something in the car hacking village, but I didn't want to risk Wi-Fi at DEF CON over that much distance. Just not a good idea. So here we just launched Metasploit. We're going to actually start using the Metasploit hardware bridge client. We'll configure it to connect to the 192.168.4.1 like router access point this is exposing. Set up the port, connect with run. And we have a session with the CANFly. The CANFly is exposing just one CAN bus at the moment. If we need to in the future, we can probably attach something to be a spy. Now I'm going to run one of the standard Metasploit hardware bridge payloads. This is just something that scrapes out a bunch of vehicle info over OBD2. So it lists all the bunch of like OBD2 PIDs you can fetch via standard commands. It grabbed them. We got the VIN. We got the calibration ID, which is one of the standard parameters on a OBD2 diagnostic connection. And we have an ECU name. So this is all running on a 3PO, our mobile car hacking lab. So some of it looks a little bit weird. Engine temp is -40°C. There's no engine. There's no engine temperature sensors. It looks a lot more normal on other things. The engine light being off is a little bit weird. I think I might have a few more bugs to fix. Being so new, the Metasploit code is still a little rough. So I actually have my own branch right now. I need to get some fixes pushed upstream, but soon.
So we touched a little bit on what you need, but here's a slide with all of that. You need the ESP32 dev board. You need a CAN transceiver. This CAN transceiver, actually, if you can find it, get the 232, not the 230. There's basically just one fewer pin you have to mess around with to get the 232 working. Yeah, just make sure if you do get a CAN transceiver, the ESP32 is a 3.3 volt part, and most CAN transceivers that I've seen are 5 volt parts. Just make sure that you get a 3.3. If you just pick up a random CAN transceiver, it's probably going to be a 5 volt part. So make sure you get a 3.3 volt transceiver. You need a 5 volt power source to, there's usually a voltage regulator on the ESP32 dev board to step down from 5 to 3 volts to power the micro. Wire, and possibly a soldering iron. Yeah, and the total cost of all this, assuming you already have a soldering iron and a power source, is less than $10.
So the firmware for this uses a IoT framework called Mongoose OS. It's absolutely miserable from a security perspective. So when you spin it up, don't run a port scan. Like, it's terrifying how many ports it has open.
That. It also crashes.
Yeah, it does. You actually compile the source at the moment by, it's like compilation as a service. I think their goal was to enable people to compile firmware without downloading a tool chain. So you post your source code to the cloud and it gives you a zip back. We're going to be rewriting this soon, so it doesn't use this
Very
framework.
soon.
It's not good, but it is simple. So the entire firmware runs on 250 lines of C. It's pretty straightforward as C goes. I wrote most of the query string parsing code at 3 a.m. without beer, so it's probably not, it's anything but bulletproof, but it works. It works. As soon as we get some time, this will be rewritten to not depend on the cloud. Looks like we are significantly earlier than I thought we would be.
Yeah.
Does anyone have questions?
Yeah, what about like other software? Is there stuff that's out there that's cheaper than like the car spy software? does the same thing where you kind of
There's
build loops of, you know.
so like the vehicle spy.
Yeah.
I don't do a whole lot with GUIs, but there are a few open source projects working on that. Do you remember any of the names?
SavvyCAN is a good one.
SavvyCAN is the one I was thinking of.
Pick up Craig Smith's Car Hacker's Handbook.
Yes.
Seriously, for real. I need to start getting a commission from him because it's an awesome book.
Have you guys looked at any of the monitoring products that like Verizon or Progressive are putting into their cars, saying, oh, we can make sure we'll prove you're a safe driver? But they're putting these products in there, and I'm going to go out on a limb and guess they have not been fully vetted as far as security.
Some of them have been vetted and taken apart as at various other.
So if you stay here, Corey Thune's giving the next talk. He's the guy who did the progressive dongle hack 3-4 years ago. So yes, these things are not. My insurance company offers them, and my car does not have one. I'll put it that way.
Do you think you could have they proven you can shut down cars with those things installed? Or?
And you can get on the CAN bus. Once you're on the CAN bus, you can do whatever you want to do.
Yeah.
Is CAN fly currently only targeting at OBD port, or everything else goes?
Whatever CAN you want to run it on. So I've been connecting it to the OBD2 port just out of convenience. If you have like some under hood CAN line or something that you wanted to connect to, it'd work for that too.
Elevators often run CAN. Whatever you can tap into.
Do you guys have any experience with J2534?
I've used it. I'm a bit familiar with it. It's just a Windows API pass-through layer to get on whatever bus you're using to flash, which in modern vehicles is almost always going to be CAN.
So you mentioned, CAN is an old protocol. It's going to be phased out eventually, but
We hope.
We only hope.
so that's kind of what I want more information on. Like, what's the next step? Like, what's going to sunset CAN? What's that going to take?
For higher speed stuff or latency critical stuff, automotive Ethernet is starting to get rolled out. It's actually kind of an interesting physical layer because it still uses 2 wire pairs, but it runs at, I think they're even introducing gigabit speeds over it. It's noise robust enough that it actually works in cars, and you get all the benefits of a Ethernet system. Yeah, the Car Hacking Village badges actually have a TGA 1100 automotive Ethernet transceiver on them. So it's interesting because it's purely point-to-point. Much like gigabit Ethernet, there's no way to passively tap it in the middle. So you actually need to explain why. It's a full duplex protocol. You can talk and listen at the same time. And the way that works is this gross oversimplification. You send messages and you subtract whatever you're sending from what you see on the bus. So if you try and tap it in the middle, you can't tell what's being sent because either side might have sent that energy. So you have a lot more security in that sense. There's no question what node something came from. Yeah.
Also, CAN coming out as supports more security functionality than the existing legacy CAN.
So CAN-FD is a protocol which was finally actually finished standardization this year, I think. It's much like CAN. It's somewhat compatible with traditional CAN devices on the same bus. It expands the data payload to 64 bytes instead of 8. So you can fit a lot more in a message.
And it's also 8 times faster, so you can get the same number of messages through.
And also FlexRate.
FlexRay is something I actually haven't worked with a whole lot, but it's a bus designed for time-critical communications. It uses a bunch of complicated time slot management techniques. So there's actually like a synchronous clock, and each module on the bus gets a slot within the bus to talk. Yeah. Anybody else? Cool.
All right, thank you very much.